Scientists, Biot and Savart are the scientists. They calculated magnetic field at a point P. What is the magnetic field? At a point P due to the current carrying conductor. Due to the current carrying conductor. Okay. See here, I am taking one current carrying conductor. It is a one current carrying conductor. Current in a conductor is I. Current in a conductor is I. We are calculating what is magnetic field at a point P. What is magnetic field at a point P we are calculating. For that one, just I am taking one small element. This is small element dl. We are dividing this total conductor as a number of elements, equal elements. In that one, small element I taken. Now in this one also current carrying is nothing but a I. We are calculating magnetic field at a point P due to the current carrying conductor. Due to the current carrying conductor. So what is the magnetic field? Just I am calculating magnetic field at P due to small element, due to current carrying small due to the small current carrying element, isn't it? So magnetic field due to the small element we are writing as a dB. That is nothing but a dB. This dB is directly proportional to first one, magnetic field due to the small element is directly proportional to current in a element. And second one, that is equation 1, magnetic field at a point P due to the element is directly proportional to length of the element. dl is nothing but a length of the element. So this is nothing but a current in element. Second one it is length of element. Okay. dB is directly proportional to sine angle between the, see here, this is angle, sine angle between the element and line joining the element and point P. So that is nothing but a sine theta. That is equation 3. This one we are writing as a sine of angle between element and position vector also you can call it is position. Otherwise line joining element and P. Okay. Sine angle between length of element and position vector. Otherwise you can call it is the line joining the element and point P. Next one, dB is magnetic field is inversely proportional to square distance between them. This is nothing but a distance between these 2 points is R if I am taking. So dB is magnetic field at a point P. Due to the small element is inversely proportional to square distance between them. It is inversely proportional to square distance between them. From equation 1, 2, 3 and 4 you can write dB is directly proportional to I, and dB is directly proportional to dl. dB is directly proportional to sine theta whole divided by inversely proportional to square distance between them. Okay. When you remove the proportionality, dB is equal to mu naught by 4 pi into ideal sin theta divided by r square. Here mu naught by 4 pi is the proportionality constant. Proportionality constant, and this mu naught value is equal to 4 pi into 10 to the power of minus 7. Mu naught is nothing but 10 to the power of minus 7, and mu naught we can call it is the permeability of free space. Mu naught we can call it is the permeability of free space, isn't it? And what are the units means? See here, what are the units means? dB unit is Tesla, magnetic field is, and r square if I am taking, that is meter square will come, and length it is divided by meters, current unit is ampere, it comes to denominator, so meter get cancelled. You can write Tesla meter per ampere, that is units are Tesla meter per ampere. That is the mu naught value. And the vector notation if you want to write, you can write mu naught by 4 pi into I dl cross r cap divided by r square. This is the vector notation unit. Here r cap is nothing but a unit vector. R cap is nothing but a unit vector, you can write there. That is nothing but a cross product. When you remove the cross, sign will be takes place again. Here a cross b is equal to, formula, a cross b is equal to ab sin theta. See here, this is a and this is b. If you take an ab sin theta will be again comes here. So this is the magnetic field, Biot-Savart law equation. It is Biot-Savart law application. See here, I am taking one current carrying conductor. Current it is I. I am taking one point B here. From the conductor to point B distance is D. From the conductor to point B distance is the D. I selected it is one element. This length of the element is dy. Length of this part. This part is nothing but a dy. From this point to length of the element distance is y. From here to a distance is the y, isn't it? Okay. This angle is theta, we know very well. This angle is theta, and this one I am writing as a angle pi. This one angle I am writing as a pi, and this is r. This distance is the r. Now we know Biot-Savart law equation, dB magnetic field at a point P due to the small element. First I am writing mu naught by 4 pi I dl sin theta divided by r square. I dl sin theta divided by r square. Actually this is the formula, but according to the diagram, length of the element, what I given the name, length of the element is dy. Length of the element, so dl is equal to, I have to write dy. dB is equal to mu naught by 4 pi, current is I, and this is dy sin theta divided by r square. Okay, sin theta divided by r square. Now this is equation number 1. It is equation number 1. First I am writing theta is equal to how much? Theta is equal to, means here this angle is 90. This angle is 90. This is pi I taken. So this theta is equal to, I can write as a 90 minus pi. See here, this angle is 90. This is pi, means the remaining angle you can write as a 90 minus pi. So theta is equal to 90 minus pi. This is equation number 2. Now I am writing tan theta. Tan theta is equal to, see here, this is one right angle triangle. It is one right angle triangle. So tan pi is equal to, this is tan pi. Opposite side by adjacent side. Here opposite side is nothing but a length from here to a distance. That is how much I had taken? Y. We taken it is y. So opposite side divided by adjacent side. Adjacent side is this one it is. What is the distance we taken? D. Adjacent side is D. Now y is equal to D if I am taking this side, D tan pi. Now differentiate this equation. Dy is equal to D into tan pi, differentiation is sec square pi, and pi differentiation is the d pi. That is equation number 3. D as usual constant, tan differentiation is the sec pi, pi differentiation is the d pi. That is equation number 3. Okay. Now sec pi is equal to what is the sec is nothing but it is the reciprocal of cos. It is the reciprocal of the cos. Now in this triangle, cos first I am writing. Okay. Cos pi is equal to 1 divided by sec pi. Okay. Otherwise, for your understanding, sec pi is equal to 1 divided by cos pi. Okay. Now this one, cos pi is equal to, see here, what is the cos pi? Adjacent side divided by hypotenuse. This is triangle and this is adjacent side and this is hypotenuse. So adjacent side is the D, hypotenuse is the R. Hypotenuse is R. So D divided by R. R goes to numerator, you can write R divided by D. Okay. Now R is equal to D, I am taking this side. R is equal to D sec pi, that is equation number 4. That is equation number 4. Substitute equation 2, equation 3, equation 4 in equation 1. Substitute equation 2, equation 3 and equation 4 in equation 1. At that moment, you can write here dB is equal to mu naught by 4 pi I dy. What is the dy is equal to? D sec square pi d pi. So d sec square pi d pi. Okay. Sin theta, I am writing sin theta is equal to 90 minus pi. Theta is equal to 90 minus pi. 90 minus pi whole divided by R is equal to, R is nothing but equation 4. R is equal to D sec pi. So D square sec square pi. Why I have written this whole square is there now? So that's why. In this one, what you can get cancelled? D and D square get cancelled. Sec square pi get cancelled. What are the remaining here? dB is equal to mu naught by 4 pi. Remaining one is I. And next one it is sin 90 minus pi is the cos pi. Cos pi d pi divided by d. 20. Now this is magnetic field. This is dB is nothing but a magnetic field at a point P. Magnetic field at a point P due to the small element. Due to the small element. If you want to find out due to the total length of the conductor, what is the magnetic field at a point P due to the whole conductor, if you want to calculate, we have to integrate that is equation. When you want to integrate that equation, integral of dB is equal to B. Okay, that equal to mu naught by I, mu naught I by 4 pi, D is the constant, integral of cos pi d pi. And limits, see here, again you have to come here, this from the 1 and 2, this end is making an angle is alpha. Okay, this end is making an angle is, this end is making an angle is beta. This total minus beta we have to write. Why we have to write here? This total angle is minus beta, this angle is alpha. Why we are writing minus beta means, see here, this is clockwise direction, positive, and this is anti-clockwise direction, minus. So direction it is depending. Minus beta to alpha I am writing, minus beta to alpha. Okay. B is equal to mu naught I divided by 4 pi d. What is integration of the sin pi d pi? Integration of the cos pi is nothing but a sin pi. So sin pi, I have written limits. What are the, after completion of the integration, the limits we have to write right side of the bracket, minus beta and alpha. Now substitute upper limit and lower limit. Here alpha is the upper limit, beta is the lower limit. Okay, beta b is equal to mu naught I divided by 4 pi d upper limit sin alpha minus, this is beta, minus sin minus beta. Here minus comes to here. So minus into minus you can write as a plus. Mu naught I divided by 4 pi d sin alpha plus sin beta. So magnetic field at a point P, magnetic field at a point P due to the one conductor, due to the current carrying conductor, B is equal to mu naught I divided by 4 pi d. Okay. Now what is the magnetic field direction? If you want to calculate magnetic field direction by using of right hand thumb rule, we have to use right hand thumb rule. See here, thumb indicate is nothing but a current direction. Thumb indicate is nothing but a current direction, and the fingers indicates magnetic field direction. The fingers indicate is nothing but a magnetic field direction. We have to place here, the current is going upward direction. We are calculating magnetic field at a point P. We have to keep our right hand like this. This is nothing but indicates current direction, and where the magnetic field we have to calculate here. So the tips of the fingers we have to keep here, and the current direction this is. So the fingers are going inside. So magnetic field is inside. Magnetic field is inside. Magnetic field is inside. Okay. For example, if the conductor is infinitive conductor I am taking. Infinitive conductor. Now this is magnetic field we are calculating. Magnetic field at a point P due to the infinitive conductor. Infinite due to the infinitive conductor. See here, from here to here distance is d. Okay, infinitive conductor means, see here, what about this angle we taken alpha? This angle we taken as a beta. If the length is increased, this angle is increasing, and if the length is increasing, this angle also increasing. Okay, I increase the length again. What is the angle is increasing? For example, if the point is on the sky, if the point is on the sky, the angle it is nearly equal to, 90 degrees. Easy explanation I will give you here. This is my cheek. If I am taking, this is a horizontal position I am taking. For your understanding, I am taking one duster like here, isn't it? This is horizontal 0. Now the point is on the sky. When I am observing on the sky like this, I can observe. What is the angle now here? 90 degrees. So when it is conductor is infinitive point, see here, while I am raising my head, the angle is increasing. So at that moment, it is nothing but a 90 degrees we have to take it. Okay. Alpha is equal to, beta is equal to 90 degrees. In mu naught I divided by 4 pi d sine 90 plus sine 90. Okay. At that moment, you can write here b is equal to mu naught I divided by 4 pi d. What is sine 90? 1. Sine 91. So that is 1 plus 1 you can write. You can write the equation, it is final equation 2 mu naught I divided by 4 pi d. If you take the infinitive conductor, this is the equation. Now Biot application we already calculated. B is equal to magnetic field at a point P due to the current carrying conductor, mu naught I divided by 4 pi d into sine alpha plus sine beta. Sine alpha plus sine beta. We calculated this one just now. Now I am taking one conductor. This is infinitive. One side it is infinitive. And now I am taking one point P is here. One point P is here. Now what is the magnetic field at this point? Due to the current carrying conductor. Due to the current carrying conductor. Just now, for your understanding, I am telling you here. Just now we taken like this. The point P is here. This is nothing but a beta angle we taken, and this is alpha angle, isn't it? But the point P is at the end I am taking. The point P I taken at the end. Now what is the angle here? The beta angle is nothing but a 0. See here? The beta. If the point P is, if I am taking here, I cannot draw the angle, it is nothing but a 0. Angle is nothing but a 0. This end and point P both are parallel. So beta is equal to 0. Beta is equal to 0. Now what about alpha? See here, infinitive means alpha angle is nothing but alpha angle is the 90 degrees. Just now I told you. When this infinitive means, we have to observe like this, that alpha angle is nothing but 90 degrees. You have to remember blindly every time. Whenever it is infinitive conductor, the point is at infinitive distance means you have to just blindly you can take alpha is equal to 90 degrees. Just now I give an example. See here, this is point. This example is very applicable for this situation. Now this is point P. The chalk is nothing but a point P. Now this is conductor like this. See here, from here to here the angle is nothing but a 0 I am taking. If I am going like this, this angle is from here to here angle is 90 degrees. Infinitive. If the conductor is on the sky, if I am taking, just I can see the conductor. This is nothing but a straight line. It will comes like a straight. So at that moment, that angle is 90 degrees. See here, this is will becomes like a straight. Angle is 90 degrees. Alpha is equal to 90 degrees. Alpha is equal to 90 degrees. Substitute in this formula, see here, like this I am taking. B is equal to, magnetic field is equal to mu naught I divided by 4 pi d sine alpha. Alpha how much? 90 plus beta. Beta is equal to how much? 0. Then B is equal to mu naught I divided by 4 pi d. Sin 91, sin 0, 0. We can write final equation. B is equal to mu naught I divided by 4 pi d. 1 plus 0, 1. So 1 into something, 1. That is something. Okay, next one. I am taking one more case here. I am taking it is the infinitive conductor, not its infinitive conductor, finite length. The length of the conductor is L. Length of the conductor is L, isn't it? Now I am taking this point P is here. The point P is here. Now from the end to point P angle is alpha. Now what about beta is equal to 0? This distance is d. From here to here distance is d. Alpha, this is angle and this is length L. Okay. What is the equation at that moment? Formula. B is equal to mu naught I divided by 4 pi d. See here, mu naught I by 4 pi d I have written. Sin alpha plus sin beta. Beta is equal to 0. Beta equal to 0. B is equal to mu naught I divided by 4 pi d sin alpha. This is the formula. Now we can simplify this equation. Sin alpha is equal to opposite side divided by hypotenuse. Sin alpha is equal to opposite side by hypotenuse. See here, it is nothing but a one right angle triangle. This equation how much will become here? Hypotenuse is equal to square root of L square plus D square. Square of opposite plus square of adjacent side. Okay. This hypotenuse is this one. So I am writing sin alpha is equal to opposite side divided by hypotenuse. Hypotenuse is this one. Under root of L square plus D square. Now substitute this equation here. B is equal to, you can write mu naught I divided by 4 pi d into L divided by under root of L square plus d square. This is one more formula. Okay. Now this point is, if you take an exactly bisector, if the point P, if I am taking exactly bisector, means length of the conductor is L. Length of the conductor is L. But I am taking here, the point P is exactly midpoint. The point P is exactly midpoint. Means from here to your distance is L by 2. From here to your distance is L by 2. Exactly bisector if I am taking. So this angle is beta. This angle is alpha. You know very well. This distance is D. Okay. This distance is D, isn't it? Now what is the formula? B is equal to mu naught I divided by 4 pi d sin alpha plus sin beta. See here, both angles are same because exactly midpoint we taken. Exactly midpoint. So alpha is equal to beta. Alpha is equal to beta. B is equal to mu naught I divided by 4 pi d sin alpha plus sin alpha. Beta I am writing as a alpha. B is equal to mu naught I divided by 4 pi d sin alpha plus sin alpha 2 sin alpha. Okay. Now mu naught I divided by 4 pi d sin alpha. What is sin alpha is equal to opposite side by hypotenuse. Here what is the hypotenuse? Square of opposite side. Square of opposite side is nothing but L by 2. L square divided by 4 plus adjacent side is the D. So that is D square. I am writing sin alpha 2 is a L by 2 whole divided by opposite side divided by hypotenuse. Hypotenuse. So L square by 4 plus D square. Okay. See here. These two get cancelled. B is equal to mu naught I divided by 4 pi d. L divided by, what is the LCM here? 4. So L square plus 4D square under root divided by 4. Root 4 I can take from the root. That is the root 2 will come. 2 goes to numerator. So final equation B is equal to mu naught I divided by 4 pi d. See here 4, it is nothing but for your understanding you will write the step. Mu naught I divided by 4 pi L divided by under root of L square plus 4d divided by 2. This 2 goes to numerator. So 2L divided by under root of L square plus 4d square. See here, this is the finite equation, exactly midpoint, bisector, and it is nothing but at a point, finite length if I am taking, but the point P is at the one end of the metal. The point P it is at one end of the wire R. Okay, next one it is one end is nothing but a free end, and what the point P is nothing but at one end. The point P is at one end. And one more, if you want to see here, I want to ask one question, children. You can, this is the current carrying conductor. I. The point P is here. The point P is here. What is the magnetic field at the point P? What is the magnetic field at a point P due to the current carrying conductors here? The point P I taken parallel to this one. Here alpha parallel. When it is taken the parallel, alpha and beta is equal to 0. Alpha and beta is equal to 0. So formula B is equal to mu naught I divided by 4 pi d sin 0 plus sin 0. Sin 0, 0 plus 0. 0 into something 0. So magnetic field is 0. You have to remember one point directly. When point P is parallel to the conductor. When point P is parallel to the conductor like this here, at that moment magnetic field is 0. Magnetic field is 0. I am taking one square. Just we are taking one square like this. Length of each side of the square it is L. Length of the side it is nothing but a L. Exactly midpoint. Now the current is passing through the square where it is nothing but like this. I current it is passing. Now we want to calculate what is the magnetic field at a point P. What is the magnetic field at a point P due to the square? These four wires are there. This is 1, 2 and third side, and this is 4. Due to these four conductors, what is the magnetic field at a point P? The point P is exactly center. The point P is exactly center. Okay. For this one, first I am taking one side conductor. See here, this is AB. This is AB. Current is upward direction. From here to your distance, what we taken? D. From one conductor, actually the formula it is like this. The point P is here. From the conductor to point P distance is D we taken. And this angle is alpha, this angle is beta we taken. Same here, this distance is D. Here D is equal to how much? D is equal to how much? See here, this total length is L. This total length is L. Exactly midpoint. Exactly midpoint means it is half of the distance. So total length is L means half of the distance is L by 2. I am writing here D is equal to L by 2. D is equal to L by 2. Then, and this is angle alpha, and this is angle beta. One is angle alpha, one more it is angle beta. And this alpha and beta is equal to what are the angle? It is perfectly square shape we taken, and exactly from the center point we taken. So at that moment, this is 90 means this is also, this angle is 45 degrees. This angle also 45 degrees. So alpha and beta both are is equal to 45 degrees. Alpha beta is equal to 45 degrees. Okay. Now I am writing formula here. Magnetic field B is equal to mu naught I divided by 4 pi d sine alpha plus sine beta. Sine alpha plus sine beta. Now substitute those values. Mu naught I. What is the D value here? 4 pi D. D is equal to L by 2. D is equal to L by 2. Next I am writing sine alpha is the 45 degrees plus beta also 45 degrees. Beta B is equal to, this 2 goes to numerator. So 2 mu naught I divided by 4 pi L. See here, sine 45. What is sine 45? 1 by root 2. 1 by root 2 plus, and this one also 1 by root 2. Then you can 1 by root 2 plus 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 mu naught I divided by 4 pi d. That is 2 by root 2. 1 by root 2 plus 1 by root 2 is the 2 by root 2. Okay. This 2 you can write. 2 how you can write? Root 2 into root 2. Root 2 into root 2 is nothing but a 2. So B is equal to mu naught I divided by 4 pi d, that is root 2 into 2 I am writing as a root 2 into root 2 divided by root 2. 1 root 2, 1 root 2 get cancelled. We can write here B is equal to 2 root 2 bracket of mu naught I divided by 4 pi d. This is nothing but a magnetic field. This is magnetic field along the AB. Due to the AB we got it. Magnetic field along the AB is equal to this one. Okay. Along the AB. See here, magnetic field, this is A, B and this is C, and this point if I am taking BC, and that is equal to magnetic field along the CD is equal to magnetic field along the DA. See here, from here to here if I am taking, the distance is L by 2. CD if I am taking angle alpha, this is angle beta, 45 degrees, 45 degrees. From due to the BC also if I am taking 45 degrees, 45 degrees. So the length is not changed. At that moment angle also not changed. That's why only magnetic field along the AB is equal, due to the AB is equal to magnetic field due to the BC equal to magnetic field due to the CD equal to magnetic field due to the DA. So all are same. That is nothing but all are same. Okay. What is the direction? Now you can write total magnetic field. Total magnetic field is equal to BAB plus BBC plus BCD plus BDA. BDA. Okay. Magnetic field due to the AB plus magnetic field due to the BC plus magnetic field plus due to the CD plus magnetic field due to the DA. This is. So total it is sum. I have written it is the all are addition. But is it correct or wrong? Total magnetic. See, by using of the right hand thumb rule again. Right hand thumb rule means the thumb indicates direction of the current. Thumb indicates direction of the current and the tips of the fingers indicates magnetic field direction. Tips of the finger indicates magnetic field direction. See here, I am placing here. Where I have to calculate at the point P. See, the tips of the finger I have to place at the point P. And the thumb indicates current direction like this. Now, magnetic field is inside or outside? It is inside. So, okay. This is nothing but inside. I am giving inside. Cross symbol is nothing but a magnetic field is inside. Next one, due to the BC, again, the thumb we have to place current direction and the tips of the finger we have to place at the P. Now, it is inside or outside? Magnetic field again inside. So, due to the BC also, it is inside. Due to the inside. Next one, here, due to the CD, we have to keep again right hand thumb rule. See here, the thumb we have to place current direction. The current direction is downward. The thumb direction also downward. Where I have to calculate magnetic field at point P. So the tips of the finger we have to place at point P like this. Now it is inside or outside? It is inside. So this is also inside. Last one, DA. DA means this is DA. See here, the thumb indicates along the current direction. Tips of the finger we have to calculate at the point P, magnetic field. This is also inside. So, Fleming right hand rule, all magnetic fields are inside only. At that moment, we can add everything. So, all are same only we can get answer. So, we can write 4, 1 plus 1 plus 1 plus 1. So, 4 it is there, 4 AB. Now 4 into magnetic field, how much we got? It is 2 root 2 mu naught I divided by 4 pi. 2 into 4, 8. So final answer we can get D is equal to 8 root 2 mu naught I divided by 4 pi D. Here what? See here, D is equal to, already we have written L. We done mistake here. So this D is nothing but a L. This is nothing but a L. D is the L we have to write. D is nothing but a L. Okay. This is the answer.